it's case 2. That means we have to go to the left first, the left subtree, and we're going to find the most right. And in order to find the most right, also, I need to do the search again, and I need to have the parent of it as well, like what we had. So I have to run it again, like what we had here. And this time, one of them is going to be the rightmost. And we're both going to start from the current element, right? So the current element. And the other one is going to be the father of it. So we have to find the rightmost. So how we find the rightmost is that we have to keep going to the right side. And as we keep going, we're checking if there is any more, if the right side become null, basically, we know we have to stop. So there's no more element to search for it. Actually, the parent is going to be the current, and the child of that is going to be the current dot left, right? So we're going to start from the left. So this is going to be the, because we do have a left child, and that left can be, by potentially, that left child can be the rightmost if there's nothing else. So if the current dot left is null, that means the rightmost children is actually the basically this element. So we're going to stop right there. So we have to keep going, and here we're going to have a while loop now. We're looking for all the rightmosts and the right side of them, right? So if whenever it's not null, we have to keep going. And immediately when it's null, we're going to stop. So if it's not null, that means now we find that the parent of the most right is going to be the rightmost is going to be the rightmost. Switching them, and so it always has to be one behind our rightmost. And so the rightmost itself is going to become the rightmost dot right. Okay, keep that in mind. We keep going to the right. So we keep going until we get to a point that the rightmost element, it doesn't have any right anymore, so that's going to be null. And we stop right there. And when we stop, then the rightmost is going to be the element that we're looking for it. So when we're out of this loop, we find the rightmost immediately. And that means that we can switch the element. So the current dot element is going to become the rightmost dot element. So we remove the currents here at this point, right? So the element, but we removed the element that we were trying to remove it, but the rightmost is basically now still there. The node is still there. We have to switch the node and get rid of it. So we know the node doesn't have any right children, but it may have left children. So we cannot just remove it by making it null or anything, right? So we need to, otherwise we're going to lose all the left children of it. So what we have to do, we need to have a if basically statement, and we're going to check. So what we have to check here, that's a very important thing you need to remember. There are two scenarios here can happen, right? One of the scenarios is that when I start searching for the most right, we get to a scenario that immediately when we're adding the current dot left, we come over here and we're checking the most, basically the rightmost dot right. And if this is null, we're going to stop. So that means the rightmost is going to be the current dot left. So if that happens, then we're going to be telling the current that we're removing to go to its, basically it's going to be the left side of its father, not going to be on the right side of its father. That's the case that we have to take care of it. So if the rightmost, okay, is equal, how about make equal method, is equal to the current dot left, that means it's going to be on the right side of, sorry, it's going to be on the left side of its parent. So the parent of the rightmost dot left is going to be equal to the rightmost dot left. Otherwise, that means we have the normal scenario that we keep going on all the way to the right to find the children. So the parent of the rightmost dot right is going to be the father of the rightmost children. So we basically we can have different cases here. We have to take care of both of those cases. So that when we get to this point, we end of case 2. What is this? So for both of the scenarios, either case 1 or case 2, when we get into the point that we have to switch the parents with the children that they're going to be missing, and we have to find a father for them. Either in case 1, they're going to be always the current right children, and in the case 2, always going to be the rightmost left children. But their parents can be in the left side or right side, depends on where is the rightmost element, or where we're trying to remove the element. So it's important to kind of take care of all those scenarios. So if we get to this point, that means we delete it. So either case 1 or case 2, that means we delete, so we can return true. And otherwise, if, so I lost the entire method. Otherwise, I have to get to this point, which is going to return false. I mean, I wasn't able to either find it or, whatever. There are some issues, so we couldn't accomplish this, what I did. So save. So this is going to be the entire analysis for our delete. So we're going to show you some examples of especially this part, so making sure that you guys understand this, why sometimes the parent of most is going to be the I have to take care of the left side of it or right side of it. So that's the one. Maybe we have to see another example for it to make sure why this part of the code is, but otherwise we can now test this and make sure everything is working fine. So in order to test that, I want to use one of the examples up on the slide that we just used. So that way, we already know what we had, and then that way we can check our code and making sure this is working the way that we expected it based on whatever we already test. So that way we also can test different scenarios, and based on that, we can go ahead and test this. So I'm going to use the example of the books. I'm going to add those data into the tests. I'm just going to leave these tests here, and then I'm going to adding these new tests. So then that I have is 20, 10, 40, 1630. Hopefully it's gonna make the same 3 in this order, and then 14, 27, 50. So to just make sure that this is similar to what we have, I want to implement a BFS because BFS is going to go level by level. We didn't implement the BFS last time, so we asked you guys to do it.